Welcome to the DIY Honda Garage channel. The DTC P0172 indicates a fuel system too rich condition in the fuel delivery system. This error typically arises due to an imbalance where excessive fuel is delivered to the engine, creating a rich air-fuel mixture. The Honda Fit models from 2015 to 2020 can experience this issue due to various factors leading to an incorrect fuel trim reading. Understanding this code is critical for proper diagnosis and repair. Before proceeding with troubleshooting, technicians are reminded to review the general diagnostic information. It's essential to avoid clearing the DTC or resetting the powertrain control module (PCM) prematurely, as this can remove critical diagnostic data necessary for accurate troubleshooting. This DTC may also accompany other fault codes which should be addressed first to ensure a comprehensive diagnostic approach. DTC P0172 signifies a rich fuel condition in the engine's fuel system, which can lead to significant performance issues if not addressed. Key components that may affect this condition include the fuel injectors, the mass airflow (MAF) sensor, and the air-fuel (AF) sensor, which play pivotal roles in managing the air-fuel mixture. The fuel injectors are responsible for delivering the correct amount of fuel into the engine's combustion chamber, while the MAF sensor measures the incoming air, allowing the PCM to adjust fuel delivery accordingly. The AF sensor directly monitors the combustion process, providing essential feedback to maintain the required air-fuel ratio. These components are primarily located in the engine compartment, and any faults or malfunctions therein can lead to erroneous readings and thus trigger the fuel system too rich error. Several potential causes contribute to triggering DTC P0172, starting with faulty fuel injectors. If injectors become stuck open or are leaking, they can introduce an excessive amount of fuel into the combustion chamber, resulting in a rich condition. Another common cause is a defective A-fork sensor, which fails to provide accurate readings for the air-fuel mixture, impairing the PCM's ability to adjust fuel delivery. Additionally, a clogged air intake or malfunctioning MAF sensor can restrict airflow, inadvertently causing a rich condition due to miscalculations in fuel delivery. Fuel quality issues, such as water contamination or wrong octane blends, can also exacerbate this condition. Each of these elements plays a role in maintaining the correct air-fuel ratios necessary for optimal engine performance. A rich fuel condition indicated by DTC P0172 leads to a variety of noticeable symptoms that affect vehicle performance. Drivers may experience poor acceleration, as excess fuel can impede efficient combustion, resulting in sluggish power delivery. Additionally, black smoke may be emitted from the exhaust, a clear indication of incomplete combustion due to a fuel-rich mixture. Decreased fuel economy is another critical symptom. If fuel is being delivered inefficiently, it can lead to increased consumption without corresponding power gains. Finally, engine stalling may occur due to flooding, where the engine's combustion process is unable to keep up with the excessive fuel supply. Each of these symptoms serves as a critical indicator for technicians to explore further diagnostics and necessary repairs. The first troubleshooting step for DTC P0172 involves verifying the problem at idle. Begin by starting the engine and allowing it to idle without load, ensuring the continuously variable transmission (CVT) is in park or neutral, or if it is a manual transmission (MT), that it is in neutral. Using the Honda Diagnostic System (HDS), actively monitor the AFFB, which stands for Air-Fuel Feedback, Short-Term Fuel Trim. This parameter should be less than 0.80. If it is, the AFFB value is indicating a too rich condition, and you should move on to step 3. If the value is acceptable, indicating normal function, proceed to Step 2 to further evaluate the situation. This analysis is essential as it lays the foundation for identifying the root cause. The second troubleshooting step involves reviewing the onboard snapshot taken with the HDS when the AFFB was at its lowest reading, accurately recording the values of the engine speed, vehicle speed, relative throttle position, TP sensor, and accelerator pedal position, APP sensor, is critical. These parameters offer insight into how the engine responded under specific operating conditions, contributing to the rich mixture. After documenting these values, the next step is to drive the vehicle under the determined conditions while continuously monitoring the AFFB. If the parameter remains low, it fortifies the diagnosis that there is indeed an issue contributing to overly rich fuel delivery. This systematic approach ensures that all aspects of the engine's performance under load are evaluated accurately. In this step, you will check the fuel pressure on the low pressure side of the fuel system. Begin by starting the engine and allowing it to idle, ensuring that you also check the AFFB. If the AFFB reading is at or below 0.80, proceed to measure the fuel pressure with the HDS while ensuring it falls within the specified range of 395 to 405 kilopascal, or approximately 57 to 58 psi. This checking is critical, as low fuel pressure would indicate potential issues such as a failing fuel pump or clogged filter. If this pressure is as expected, it confirms that fuel delivery is functioning adequately on the low pressure side. If the pressure does not meet specifications, the next logical step is to replace the fuel tank unit or further investigate upstream fuel systems for faults. Step 4 focuses on verifying the fuel pressure in the high-pressure side of the fuel delivery system. Start by turning the vehicle to the off mode, then switch it back to on. Using the HDS, clear the DTC to refresh the parameters before starting the engine again. Once the engine is running, maintain the engine speed at 3000 RPM without load until the radiator fan engages, which indicates sufficient conditions for testing fuel pressure. Select the DI fuel pressure test in the HDS inspection menu to determine if the HDS indicates a normal status. If it doesn't show normal readings, deeper investigations must be undertaken using diagnostic approaches for DTC P0087 and P0088. This methodical approach helps ensure that the entire fuel system is functioning correctly under operational loads. In Step 5, the focus is on the fuel itself, as the quality can significantly impact engine performance. Start by turning off the vehicle and draining the fuel from the tank. It's critical to refill the tank with known good fuel to test against any previous quality issues. After refilling, start the engine and let it idle. Then operate the vehicle as per the previously documented conditions where the AFFB was 0.80 or lower. After driving, monitor the AFFB once again. If it is still low, it suggests that the fuel quality was indeed a contributing factor, and corrective actions, such as investigating fuel source or storage, are needed. If now within specifications, it may allow you to advance the diagnostics further down the logical path in addressing the root cause of the original DTC. Step 6 requires you to check the performance of the MAF sensor, a pivotal component for accurate air-fuel mixture calculation. Keep the engine idling after the previous tests and ensure the engine coolant temperature, ECT sensor 1, is above 158 degrees Fahrenheit or 70 degrees Celsius to meet operational parameters. CVT should remain in P or N or MT in neutral. Hold the engine speed at precisely 2500 RPM for about 30 seconds while you monitor the MAF sensor values using the HDS. The expected readings for a manual transmission are between 3.8 and 5.4 grams per second, and for a CVT, between 3.9 and 5.5 grams per second. If the readings fall within these parameters, the MAF sensor is functioning correctly, and you can proceed to the next step. Any discrepancies require further investigation of the air cleaner assembly for damage, or, in some cases, direct replacement of the MAF IAT sensor components. The seventh step involves checking the engine oil's condition, as it can also impact fuel trim values. While the engine stays idle, gently pinch the PCV, positive crankcase ventilation vacuum hose. Monitoring the AFFB at this point is crucial. If it remains below 0.80, it suggests that the engine oil is likely contaminated. Contaminated oil can lead to increased blow-by gases, influencing the fuel trim readings and subsequently causing a rich condition. Identifying the source of contamination, be it from faulty injectors or other leaks, will require addressing those specific issues. If the oil proves to be contaminant-free, you might eliminate it as a factor in this DTC. Should you find contamination, an oil flush along with replacements will be necessary to restore engine responsiveness. Step 8 involves assessing the EVAP, evaporative emission control canister purge valve, as it can cause fuel enrichment if malfunctioning. Start by turning the vehicle to the off position and disconnect the 2P connector from the EVAP canister purge valve. Next, detach the vacuum hose from the purge valve, connecting a vacuum pump to assess whether the valve can hold vacuum pressure. If the vacuum pump indicates a vacuum, it signifies that under warm conditions, fuel vapors are entering the intake manifold excessively, creating an overly rich mixture and potentially causing stalling. In this case, replacement of the EVAP canister purge valve may be warranted. If no vacuum is indicated, further steps should be taken to address other potential causes in the EVAP system or fuel delivery configuration. The ninth troubleshooting step involves the potential replacement of fuel injectors. Begin by turning the vehicle to the off mode and swapping out the existing injectors for a set known to be functioning properly. After the injector swap, restart the engine and let it idle to ensure a smoother operation. Next, operate the vehicle at the same conditions previously defined, where the AFFB was low. Monitor the AFFB once more to see if this replacement rectifies the rich condition. If the reading indicates low again, the injectors may have been the root cause, and it would necessitate checking all injectors to ensure a set replacement for effectiveness. Failure to correct the issue at this point means that the diagnosis must move forward to other components. The last troubleshooting step centers around the AF sensor, which may potentially be responsible for incorrect readings, prompting DTC P0172. To begin, switch the vehicle to the off position and replace the AF sensor, sensor 1, with a known good sensor. Start the engine and allow it to idle for assessment. Next, operate the vehicle under the predefined conditions to see if the AFFB reading stabilizes above the threshold. If it does, there was an issue with the original sensor, and this replacement resolved the rich condition. Should the issue persist, consider going back to install the original sensor and explore the substitution of the PCM, as it may be a potential failing component at this stage. Each action taken at this step provides critical opportunity to rectify the fuel management system. Final verification is essential to confirm that previously performed repairs have effectively addressed the DTC P0172. Begin by reviewing all repair outcomes to ensure each step of the diagnostic process was followed correctly, confirming that any replaced components were functioning appropriately. After verifying the repairs, check to ensure that no DTCs are presently logged within the PCM. Conduct a thorough road test of the vehicle under varying driving conditions to evaluate performance, ensuring that the symptoms associated with a rich fuel condition have ceased and the engine is responding normally. This verification process is crucial to ensure the long-term reliability of the vehicle and maintain its performance standards. Preventive maintenance plays a vital role in mitigating the recurrence of DTC P0172 and ensuring optimal vehicle performance. Regularly checking fuel quality is critical. Using fuel from reliable suppliers and ensuring no contamination occurs can minimize future issues related to the fuel delivery system. Monitoring engine sensors, particularly the MAF and AF sensors, will assist in identifying problems before they result in more significant failures, allowing for timely interventions. Additionally, adhering to a routine maintenance schedule for oil changes ensures the engine operates smoothly and avoids contamination that could throw off fuel trims. Implementing these preventive measures can significantly enhance the longevity and reliability of the Honda Fit. In conclusion, understanding and effectively addressing DTC P0172, which indicates a fuel system too rich error, is of utmost importance for the Honda Fit models from 2015 to 2020. Key causes range from faulty injectors and sensors to fuel quality issues, each necessitating a thorough diagnostic approach to ensure accurate repairs. Throughout the troubleshooting steps, technicians must adhere closely to recommended practices, avoiding premature clearance of DTCs to retain vital diagnostic information. Furthermore, the integration of regular maintenance into a vehicle's routine can significantly reduce the risk of recurrence of this DTC, promoting both efficiency and longevity in vehicle performance. By keeping these points in mind, one can safeguard the functionality of the Honda Fit, preserving its reliability on the road. Please like and subscribe to the channel. See you next time.